welcome back to my channel. Glad to see you guys again here. So today we are going to talk about how to use Excel to plot StressStrain Curve after you complete your tensile test. So after the tensile test, you're going to collect some data, including the force and elongation in every 15 to 20 seconds. And also you're going to measure the cross-sectional area as well as the length of the specimen. So your specimen will be looking like this, and you're going to measure the cross-sectional area here. And we are also going to use a punch and make 2 points on the specimen with the distance about 2 inches. And after that, we are going to do the data analysis and also create the plot for StressStrain Curve. So let's get it started. So first of all, let's calculate the stress. So stress is force over area. So let's put an equal sign, then click on A2 and divide it by area, then hit enter. And then you click on the cell and hover your mouse to the bottom right of the cell. Then you can double click on it. But before we do that, you will get an error message. Oh, looks like this. So let's see what's happening. So if you click on, let's see, C4, then looks like they used A4 as well as I4. So we actually don't want to use I4. We want to keep using I2 here. So we will need to lock our I2 number here. So basically in Excel, which number you want to lock, you are going to put a $sign in front. So let's hit ESC to get out of the cell, then click on C2 here and click on 2 and put a $sign in front. So I2 is going to be locked. Then hit enter after you're done. Then double click on the black cross again. Then those are our numbers. The next thing, our units are supposed to be in KSI, which is kilo pound per square inch. So we will also need to divide it by 1000 for all these numbers. So let's click on the first one and divide it by 1000. Then hit enter, then double click on it. So those are our numbers. All right, next one is strain. So strain is elongation divided by the original length. So let's tap equal elongation divided by the original length. Then hit enter, then double click on it. And the same thing, we need to lock this number here. So let's lock 3 over here by putting a $sign in front, then hit enter. Then do it one more time. And that's our strain. Then let's save the work. With the stress and the strain data, we can plot the StressStrain Curve. So let's click on Insert and go to Charts. And for the chart tab, let's look. So we probably want to use scatters for each point. So let's click on the drop-down button of a scatter. We probably want to use a smooth line to connect all the points. And click on it. Now we have a blank chart. Then let's add data there by right-clicking on the blank chart and click on Select Data. Then add the series name. So for the StressStrain Curve, the x-axis are strain and the y-axis is stress. So the series name is talking about the y-axis. So it's going to be stress. So let's click on C1. And for the x values is all the D's. So select the first one until the last number that you have. And for y, let's delete the current one and select all the C column. And looks right, then say OK. Then say OK. Next one for the grades. So we probably don't want to use the vertical grades. So let's click on one of them and hit the delete key, and they are gone. The next one, let's think about the decimal places. So we probably don't need another 2 decimal places here. So let's click on the numbers, then right click of your mouse and then click on Format Axis. Then go down here, click on number and change it to 2 decimal places. Then hit enter. A similar thing, we probably don't want 2 decimal places in the y-axis either. So let's click on the numbers and change it to 0. Then hit enter. Then close the window. Okay, and for all the charts, we need to have a title and also the x-axis description and also y-axis description. So let's add them. So let's click on the chart. Then you're going to have another tab, chart design. So let's add a chart elements. Then first of all, add a title. So above chart, this looks good to me. So the chart is going to be a StressStrain Curve. And also when you do the test, you're going to identify your material. If it's 1020, then we are going to tap AISI space 1020 StressStrain Curve. And also we are going to give the x-axis title by clicking on add chart elements and primary horizontal, it's strain, enter, then add y-axis, which is stress, enter. And also for stress, we do have a units, which is KSI. So let's add here as well, KSI. And for strain, it doesn't have units because it's an inch over inch. Okay, then let's save the work again. Now, with all this data, so let's estimate the yield strength point as well as the strain at that point, and also ultimate tensile strength point as well as the strain at that point, also the maximum strain of the material. So for the yield strength, so it looks like until this point are still linear. So maybe this point here. So it looks like it's at 85 for stress. So maybe it's this point here. So let's make it to be orange. Then this is also the corresponding strain. And the next one is ultimate tensile strength, which is going to be the highest number here. So let's look. And for this material, looks like it's 96.25. So you could use either one. So I'm going to use this one here and then make it to be orange. And also the corresponding strain is going to be this number. And the last one is the maximum strain. So it's going to be the highest strain, which is the very last number, and highlighted it as orange. And let's type in all those numbers. So for yield strength, it's 85, and hit enter. And the strain at this point is 0.0220. And the ultimate tensile strength is 96. Let's go here. It's 96.25. And the strain is this number. And tap it here. It's 0.0485. Then enter. Then the maximum strain is 0.1080. Then change it here. 0.1080. Then hit enter. Okay, next one is calculating Young's modulus. So Young's modulus is defined as stress over strain in the elastic region, which is also the slope of the curve. So Excel is actually have the built-in function for calculating the slope. So let's go to this cell here, then tap enter, then tap in slope. So this is the function of the slope. So double click on it. Looks like we need to put all the y values and all the x values. So for the y values, they are stresses. And for x values, they are all strain. So for y value, they are stress. So we only select in the elastic region. And after you're done, then tap a comma. So we are going to the next parameter, which is a strain. So comma here. The next one is a strain. So once again, we only select the elastic region. So select all those numbers here, then close the parentheses, then hit enter. So it looks like this is the slope. So it's a 3,919. Then we probably don't need this 4 decimal places because we're talking about 3,900. So let's click on this number and remove the decimal places. Okay, this looks good. And this is going to be our Young's modulus. So let's put it here. So the units is still in KSI. Then hit equal and select the cell here. Then hit enter. Then it's going to be here. Okay, next one, we are going to create the 0.2% strain to get the yield strength of the material. So first of all, before we create the 0.2% of the strain, we probably need to create a curve that shows the elastic region of the material. So let's plot the elastic region first, which are going to be these points. So let's click on the graph, then right click on it and select the data. And we're going to add another trend. The name is elastic stress. And the units is still KSI, parentheses, and x-axis is going to be strain, so only until the elastic region. And for y-axis, delete that, and until the elastic region. Then say OK, and say OK, and save the work. So now we have two trends now. This color one is only in the elastic region. And now we want to create the 0.2% of a strain. So we are going to create another line that is parallel to the existing line, but shift 0.2% to the right. So from your algebra, if we are doing that, all the x numbers are going to be added 0.002, but for all y numbers, they remain the same. So let's do that. So we are going to add all your x numbers 0.002 and remain all the y numbers. So this is your x number. So we tap equal and select the string plus 0.002, then enter, then drag it down. So we probably want to have one more additional one. So we are going to have an intersection point with the other line. So we select one more. So for stresses, which is your y-axis, and remember, they remain the same and it does not change. So you could use the original stress numbers here and drag it down. But instead of using this, I'm going to use Young's modulus. So from your algebra, so y equals to kx. The strain we select is going to be the original strain, not the 0.2% offset ones. So equal y equals to kx. So k is your Young's modulus. And once again, we want to log 5 here. So put a dollar sign in front, then times, so kx, then x is going to be your string. So click on this number, then hit enter, then drag it down here. And we probably don't need this many decimal places. So let's change it to 2 decimal places. Then save your work. Okay, then let's plot this 2% elongation line. So let's click on the chart, then right click of mouse and select the data and add a new one. Then the name is going to be the cell here. Your X values are going to be the new strings. And your Y value is going to be this column here. Then looks right to me. Then say OK. Then say OK. Then save your work. Now we need to add legend to this curve here. Otherwise, nobody knows what are these 3 curves are. So let's select this curve and chart design and add element and legend. So maybe let's put it to the right. And we probably can move it here and select the curve again, make it bigger, and the legend here. And we probably want to highlight this part and put a box around it. So right now it doesn't have, so let's put a box around it. Also make the background to be white instead of transparent. So let's click on format, then shape fill, let's do white. And the shape outline, let's make it to be black. Then if you think this is too thick, you can change the weight lighter, then save your work. Then looks like our 0.2% yield strength is the intersection point here. By eyeballing the part, looks like it's probably 91, I would say. So let's put 91 here. Okay, looks like we are done of this assignment. So this is how to plot StressStrain curve with the 0.2% yield strength included. All right, thanks for watching the video. We'll see you next time. Bye.